Hello everyone. Welcome to my YouTube channel of Geography Lecture Series. Uh, Today we'll be discussing about the atmosphere. Before going to going to topic, discussing the topic, so let me introduce myself. My name is Saad Rahoojo. I'm from Geography Department, University of Sindh, Jamshoro. So as you know, we are being in lockdown and social distancing. Everything is being now closed. Mostly the education institutes are being closed. So looking at the situation, we need to have some sort of alternate. So the Higher Education Commission has come out with some solution, with some alternate. So one of the alternate is the online classes or virtual learning or distance learning. So keeping in view all these things, I have also started the lecture series, especially on the geography. So today we will be discussing about the atmosphere, which is very popular subjects in geography. Actually, atmosphere is one of the domains, four domains of geography. There are four domains, and as the geography, most of the geography students, they know about the domains of geography. Actually, domains are the critical, are the core of geography. So if you study, if you have been learning about these four domains, it means you are being almost what I say, covering 80 to 85% of geography. So what are these domains? Like we have an atmosphere, we have a lithosphere, we have a biosphere, and we have a hydrosphere. So these four domains, they cover almost most part of the geography. These are being mainly discussed. You can say the geography revolves around these four domains. So as I told you, we have been discussing the atmosphere today. But regarding these domains, I will make a separate video on, or the lecture video on these four domains. So hopefully in the future we will come out some more videos. So let's start discussing the atmosphere. The why. Yes, go over here. So in this lecture, we will discussing especially what is atmosphere, what is the composition, structure, and the profile of the atmosphere. So let's have a brief or detailed discussion about the atmosphere. As you have been looking at the slides, it's been said Earth atmosphere. Why is it important for life? Or you can say generally, you can say why the atmosphere is important. Now, look at atmosphere. If you compare the planet Earth with the rest of the planets in the solar system, uh, uh, if you look at them, every planet have atmosphere. They have atmospheres, but the atmosphere which with the Earth has is a particular one. It's something like, uh, it's a combination of certain climatic element, or a combination of certain elements or the component which it's more suitable for the life. So if you look at the other planets and compare with the Earth, so, the Earth atmosphere is more suitable for life. So if you look at the matching or the combination or amalgamation of the different climatic elements or the things which are present in the atmosphere or the atmosphere as a whole, it support the life. So this atmosphere doesn't existing on other planets. Now those planets have some sort of atmosphere, but if you look at the combination of the gases or water vapors or dust particles, you don't find these are being supporting the life. So Earth planet has an atmosphere which supports the life. You can say the Earth is the only planet in the atmosphere which has the life. It is only because of this atmospheric composition or this atmosphere. So today we'll discussing the atmosphere as I told you before. Let's go to the definition of the atmosphere. So atmosphere is a thin layer of gases that surrounds a planet Earth or moon held by the force of gravity. So atmosphere, it is the, the mixture of gases. Uh, it is the air which surrounds our Earth. It is similar like, when we are being lying on the bed and we put on the blanket. So then we see our whole body is covered by that blanket. So similar like, the atmosphere is covering our whole Earth. It's been surrounding our Earth. So atmosphere is air, is a mixture of air, a combination of air. So that air is being formed of different gases. So we'll discuss in our coming slides what are those gases which are present in atmosphere. So about 99 of the atmospheric gases, including water vapor, extend only 30-kilometer surface. So if you look at the profile, layeric composition or layers of the atmosphere, when we were discussing the layers of the atmosphere, we will see first two layers, troposphere and the stratosphere. They are more important in terms of climatic change, or you can say generally for the climate, because we are being influenced by the climate where we are being living. Climate is more important. So about 99% of atmospheric gases, including water vapor, extend only 30 kilometers above the surface. So if we go from beneath up to the top, from low to the top, we'll see the 30 kilometers are important. So where we can find 99% of atmospheric gases and water vapor. We also been discussing the atmospheric composition, you will see. So most of our weather, however, occurs within the first 10 to 15 kilometers. So this is also important because in atmosphere, mostly we are being concerned to the climatic elements, which are climatic elements means air, water or water vapors, or you can say rainfall, or humidity, pressure, winds. So these are important, or which are make our atmosphere. So if you look at the, the weather condition or weather, it's 10 to 15 kilometers are important, where we can say we must have to concern, or we need to have a knowledge of 10 to 15 kilometers. So the evolution of atmosphere. Let's discuss the evolution of atmosphere. The early atmosphere did not support the life. It contained deadly gases such as methane and ammonia. There was a very little oxygen. So if you look at the composition, which we will discuss, this is the composition of atmosphere. In Earth atmosphere, it is composed of gases. There are different gases. Then we have a dust, we have water vapor, we have a smoke, and we have aerosols and the pollutants. So what this thing says, it is been said that early atmosphere at the beginning. So if you go back to the history, like when we discuss about the universe. So our universe came into being some 14 billion years ago because of the Big Bang. There's a sudden blast. So after that sudden blast, we are not going to be in discussion. I will have another video on that, evolution of universe or the Big Bang theory. So in a Big Bang, a sudden blast, our universe came into being, and it happens 14 billion years ago. So once the universe came into being or been formed, then there was, slowly and gradually rest of the things came into being. So आहिस्ता आहिस्ता उसके बाद चीजें आने गई. If you talk about the Earth, our Earth came into being 4.5 billion years ago. 4.5 billion. So it's almost 10 billion. The lots of time. So 4.5 billion ago, 4.5 million ago, our Earth came into being, and it came, once the solar system will evolve. So we are the part of solar system where we have a sun, which is a central part, which is a central position. Then we have a rest of the planets. So Earth is one of them. So our Earth came into being 4.5 million. Then the life on the Earth, which is more important, life, living things, life. So you can say it came 225 million years ago. So it took time. The life Earth was made earlier, but the life on the Earth came so late. So what was the reason? Reason was the what is it? the atmosphere, because atmosphere supports life. Now, the atmosphere was there, but the composition, the atmosphere which was at the moment, at that time, wasn't supporting the life. So that atmosphere had the gases. That atmosphere had the deadly gases, means the methane, ammonia. So the concentration of methane and ammonia was so high, so that it could not support the life. Because of these deadly gases, the life didn't come on the on the earth. So there was a little oxygen, and oxygen is also important. It is a life. Over the time, gases were added to the atmosphere for volcanic eruption and the rest of chemical reaction due to the sunlight. So suddenly, slowly and gradually, some process happens. So one of them was volcanic eruption. So once the volcanoes were erupted, there is endogenous and exogenic forces or some geological processes. So once the volcanoes were erupted, so they are being emitting some sort of material in the form of lava or magma. So that material become the part of our atmosphere slowly growing. So the gases which were inside the what I say which were inside Yeah. So which were inside the earth or beneath the earth, they slowly and gradually become the part of atmosphere. So slowly and gradually, our atmosphere start to change, and the atmosphere now we have, once they got the gases which was supporting the life, and one of them was the oxygen. So at that time, oxygen was very less. Now we are coming to the composition I told you before. So Earth's atmosphere composed of gases, dust, water vapor, smoke, on these also. Let's go. So atmospheric, what are the atmospheric gases? I've been telling you that our atmosphere is mainly comprised of the different gases. So now we have to see which are those gases. So the nitrogen, oxygen, argon, water vapor, carbon dioxide, and most other gases are invisible. So these are being gases which are being now visible or invisible. We can't see them, but we can. So clouds are not gas, but condensed vapor in the form of liquid droplets. So if you look at the what I say the there's a certain process like the water which is being evaporate. Once it's been evaporating under certain circumstances, like the temperatures when the temperature is high, so that water start to evaporate and goes up in the environment or in the atmosphere or in the air. So again, there is another condition which we call the condensation. So that water vapors, they again form or come into the form of droplets. So then we have another process which is called the precipitation. So I'll also have another video on the precipitation, condensation, and evaporation. These are the other processes. So ground-based smoke, which is visible, contain reactant of the nitrogen and the ozone. So we have a gases, then we have a dust, then we have a water vapor. So after water vapors, we also have a smoke. Smoke, you can see them. These are the visible things. So once our industries, factories, when we're running them, they are been running on the power. They are emitting something, or something which are been coming our houses, homes. So they leave something which become the part of, or they emit something, some gases which goes up in the atmosphere and become the part of the atmospheres. So now we are coming to these gases. So by volume, if you look at the concentration amount or the volume of the gases, so the nitrogen and oxygen are the dominant gases in the atmosphere. So these are the two gases which are leading gases, which are very high in number or the amount. So together these two gases make up approximately 99% of dry atmosphere. So what with the atmosphere we have, if you talk about these gases, 99% gases, in amount, in terms of amount or concentration, 99% are being covered by the nitrogen and oxygen. So nitrogen and oxygen combined together, combinedly, they make the 99% of our atmosphere. So both of these gases have very important for life. They are so important that everyone have their own, So nitrogen is removed from the atmosphere and deposited at the Earth's surface mainly by specialized nitrogen fixation, bacteria, and by way of through precipitation. So it's a similar like, nitrogen fixation is a process similar like a hydrological process or a water cycle, similar like, so if you know the water cycle, the water is being, moved from bottom to up to the atmosphere, and again it comes down. So it is being moving. It has been moved. Similar like nitrogen fixation. So similar the water once being moving or being in a cyclic form, the amount of water is same, but it's being, it's all about the distribution. So we're not be discussing here. So nitrogen fixation is the same process. Like, it is a fixed amount, but it's been rolling, it's been moving, from atmosphere. It goes down, it's come to the surface of Earth in the form of precipitation once we have a rainfall, and again it has been become the part of atmosphere once we start to burn anything or agriculture. So by the way of through precipitation, the addition of this nitrogen to the Earth's surface, soil, and various water bodies supplies much needed nutrition for the plants. So very important. Nitrogen is very important. It is a supplement, the nutrients for the plant's growth. So nitrogen return to the atmosphere primarily through biomass combustion. So when you have been burning these plants or the so the trees, again this nitrogen goes back to the atmosphere. So after the combustion or burning of these biomes, it goes to the atmosphere. So oxygen, now we are coming. Oxygen is exchanged between the atmosphere and the life through the process of photosynthesis and the respiration. We don't need to discuss in depth, because everyone knows about this. This is a popular topic. So oxygen is important for the life. We inhale oxygen and exhale carbon dioxide. So it's very important. This case is very important for us, and it's been present or remain in the environment, and we get the oxygen, the process of photosynthesis. So I'm not going to this detail. So if you look at here, if you look at the portions or the amount or the volume of the oxygens, sorry, of the gases, different gases. So now we have a nitrogen, which is chemical formula is N2. It is 78.8%. And the oxygen O2, we have a 21.9%. So almost 78% the nitrogen, the amount of nitrogen which is present in the atmosphere, and the 21% is the oxygen. So if you combine both of them, these are the 99% of the atmospheric composition. The rest of other things, water, which is 0.20 to 5%, because water has been varying. Now it has been present in the form of water vapor, but it depends where it has been there. So argon, the another gas which is 0.93, carbon dioxide, CO2. Which is the talk of the time, which is being talking, regularly by the people, environmental experts, the amount of carbon dioxide present in the environment. So this gas has a significant impact in the environment or in the atmosphere. So we'll talk on later on this, how carbon dioxide have an impact on the environment. So now if you look at the portion of carbon dioxide, which is 0.0360, which is very, very minute, very little, which is nominal, but it's still, its impact is very high. Then we have a neon, we have a helium 0.005, we have a methane gas, which is 0.0017, we have a hydrogen 0.00, and nitrogen oxide. So if you separate the rest of the gases from two main gases, nitrogen and oxygen, they are just 1%. They are 1% by volume in the atmosphere, but their impact is very high. So I'll also discuss about the carbon dioxide. So now we are coming to this fifth dominant gases, which is called the carbon dioxide. So you have been, you have been listening or hearing now and then in media, in the newspapers, and the articles about the environmental pollution, about the global warming, about the climate change. So all these issues are mainly, or you can say, because of this carbon dioxide, the amount of carbon dioxide which are being present in environment. So the volume of this gas has increased over 35% in the last 300 years. So if you look at the history of carbon dioxide, slowly, gradually, its volume been increasing. So it has been 35% increase in last 300 years. So you can say as the life goes, so we have been, like we want to have a more luxurious life, more comfortable life. So where we are being, converting our land from, from the barren or from agricultural land to the residential area. There's more and more urbanization. Our life has become so mechanized, so organized, where there are everywhere we have devices, or you can say machines. So there's lots of involvement of machine in our life. So we are making our life comfortable and easy. So like the industries or factories or even the transportation we have, we are being, moving from one place to another another place on by. So we are moving, are being traveling by road, by air, by water. So all these machines, all these vehicles run through some sort of fuels, and the fuels when are being burned, as being, running, so it emits, it releases the carbon dioxide. So carbon dioxide, is increase. It's similar like when you see our life has become easier when we are being like using more and more machines, and similarly the carbon dioxide are being increased because most of them are being depending on the consumption of the the fuels, and fuel is the carbon dioxide. So the increase is primarily due to the human induced burning from the fossil fuels, deforestation, and other form of land use change. So when we have been changing our land, or we've been digging our land, or been taking its changing its landscape, constructing buildings, putting something, or doing mining. See these, or we have a deforestation or the use of fossil fuels. They all been increasing. Oh, sorry, all been releasing the carbon dioxide. So carbon dioxide is an important greenhouse gas. It's one of the human cause increase its concentration in the atmosphere has strengthened the greenhouse effect and has definitely contributed to global warming. So over last 100 years, carbon dioxide also, so carbon dioxide is also naturally exchanged between atmosphere and life through the process of photosynthesis and respiration. So carbon dioxide become the part of our life because when it goes up, it becomes the part of atmosphere. Once they have an ozone layer. So when they reach there in ozone layer, we have a precipitation or the rainfall. It comes down, and again the part of our life. So we have been carbon dioxide issue. So because of carbon dioxide, because it's a greenhouse gases, so we have an issue of global warming, means increase in the temperature, or the climate change. In climate change, we have an irregular rainfall, or you can say scant rainfall, or no rainfall, or high rainfall, what we call them. So climate change is quite a very very difficult thing to, like, it has a it has a different impacts. Sometimes we have a high rainfall, sometimes we have a low rainfall, sometimes we have irregular rainfall, sometimes we have a scant rainfall. So, and similar like in terms of temperature, where we have a high temperature, low temperature. So carbon dioxide contribution is very high. So climate change, global warming, these all are the issues of which are being coming out from the increase of the carbon dioxide. So once we had a carbon dioxide increase, so it's still like, we have been talking about the, global warming or the climate change what we have. So the world is being concerned because of the increase in the carbon dioxide, it is having a negative impacts on many things, especially on the environment. So where we have a pollutions of different forms, air pollution, water pollution, what we call different pollution. So the environmental experts, they are always they are been always what you say admonishing, or being informing the world that look, the increase of carbon dioxide being, it's alarming edge. So we need to stop it, we need to restrict it. So looking at all these things, I've been keeping in mind all these things, the different what do you say, the global organizations, one of them the UNO. So they are been working in different forms to reduce or to restrict or limit the carbon dioxide. So they have come out with some, what is some pacts or some agreement or some laws. So one of them was the the Montreal Protocol. So the Montreal Protocol is international treaty on substance that deplete the ozone layer. You will understand the ozone layer when we will talk about the composition, profile, layeric profile of the atmosphere. We'll be discussing troposphere, stratosphere, and stratosphere. We have an ozone layer. So उसके बाद आपको समझ में आ जाएगा. But before this, I want to discuss with you this pact or this agreement, which is called the Montreal Protocol. So this protocol came out, or this treaty came out when the experts saw that our ozone layer is being depleting, ozone layer is being degrading. So they came out some laws. So one of them was the Montreal Protocol. So it was a landmark of multilateral environmental agreement that regulated the production and the consumption of nearly 100 man-made chemicals referred to the ozone degrading substance. So this pact shows that there are certain chemicals on a they nominated, or they mentioned 100 of them, which are deadly, which are have a negative impact on the ozone. So they want to have a restriction on these chemicals, so our ozone may refresh or restore itself. So when these substances are released to the atmosphere, those chemicals damage the stratospheric ozone layer. So once we have been releasing these chemicals, the chemicals become the part of air or the atmosphere. What they do, they damage our ozone layer. So Earth's protective shield, that is protect human and the environment from harmful. And you all be knowing that what is the ozone layer? Ozone layer is a layer, एक तह है, which has been protecting us from the deadly gases or ultraviolet gases. So this resolution was passed on 15 September 1987 and was implemented in 1989. So this protocol is the only agreement by the UNO that has been ratified by all 197 UN members. So this pact came out on 1987, 15 September 1987, and it was implemented after 2 years in 1989. But the important things to learn here are that this pact was ratified owned by or seconded by all 197 members of the UNO. So now what UN has been doing, so these protocols are being, every year they are being, judge or determined that how the governments or different governments or the countries, they are being following protocols. We are not coming on that whether it's being these protocols are being followed in its true sense, or still there are certain countries which are not being serious about that. So this is another discussion. Now again, there is another pact which is called the Kyoto Protocol Pact, which is just also being about the consumption or emission, what it's called, consumption of deadly gases or emitting of the deadly gases in the environment. So the Kyoto Protocol, it was called the Kyoto Protocol. The Kyoto Protocol insists the industrialized countries to cut their greenhouse gases emission gradually in the wake of alarming threats of global warming. So again, we had another pact, another agreement, which came into being in 1993. It happens in Japan, Kyoto, Japan. So this protocol, this pact, insists, pressurize the industrialized countries to reduce the greenhouse gases, because global warming is being, or the temperature of being increasing. Global temperature is being increased at a alarming rate. So the protocol was linked to the United Nations Framework Convention on Climate Change. So in the UN, we have a one part which is called the Climate Convention, which is working on the climate change. So it was adopted in Kyoto, Japan, December 1997, and became the international law in February 2007. It happened in 1997, but became the part in 2005. So it took almost 8 years to become the. But again, the countries that ratify the Kyoto Protocol were assigned maximum carbon emission level for the specific period and participate in carbon credit trading. If a country emitted more than its assigned limit, then it would be penalized by receiving lower emission limit in the following period. So there was some sort of format where the countries were categorized, especially the industrialized country. They were categorized and classified. So the portion of use of carbon dioxide, use of fossil fuels were given to them. Like there was a limit put on them by looking at the environment or the industrial infrastructure or the network of those countries. They were told that you have to use certain amount of this fossil fuels or these gases, the power for their industry. So if they are being increasing, exceeding from their limit, they are going to be fine in the coming years. So कहने का मकसद ये है कि उनको एक लिमिटेड नंबर ऑफ दिया गया कि आप इतना कार्बन डाइऑक्साइड यूज कर सकते हैं. अगर आप इससे आगे चले गए तो then you are going to be fine in the future. Oh, but thing is there, the industrialized countries made a promise under the Kyoto Protocol to reduce their annual hydrocarbon emission by average 5.2% by the year 2005. So at that time, these all countries were agreed that okay, we are going to reduce the hydrocarbon emissions by the average 5.2% by the year 2012. तो उन्होंने कहा कि 2012 तक हम इसको 5%, 5% इसको कम कर देंगे. तो this number would represent about 29% of world's total greenhouse emissions. So अगर सबको मिला के आप कहें तो that number may be 29% of world's total greenhouse gas emissions. So ये 29% हो जाएगा. This means each nation had a different target to meet that year. Members of European Union pledged to cut emission by 8%, while the US and Canada promised to reduce their emission 7% and 6% respectively by 2000. So these industrialized or developed countries, they agreed that okay, we are going to reduce, and so they mentioned that how much they are going to be reducing. So they showed the percentage. So European Union, the 8%, US and Canada promised 7% and 6%. So if you look at this fact, it says that the industrialized country, they have to, cut down or limited their emissions, carbon dioxide. But thing is that if you look at because why we call them the industrialized or developed countries, especially why we call them developed, because they are developed because their economies are strong. And they are developed because they have an industry. So their industries, they have been running on on these fossil fuels, on the power. So if they reduce the power, or you can say if you reduce the running of their industries, so it means they are going to affect their economy. So I don't think so. Anybody is going to reduce a limit. So because it will shorten their economic growth. So now this pact was this pact was owned by all countries, most of the industrial countries, but they are not being serious. They are not being following in its true sense. They feel that once they stop or limit their carbon dioxide emissions, or you can say the industry, so it's going to affect their economic growth. So if their economic growth is being reduced or being affected, it's going to weaken their political strength. So these developed industrial countries, they are also being politically strong. So once their economies are being weakened, there is a less political say in the world. So I'm going to stop the lecture here. So I will continue that lecture in my another video, and we will be talking about the about the composition, profile, where we have a different layers of atmosphere in our next video. So stay tuned, stay with me. So there will be another video.